Everyone seems to know that some fish stocks around the world are in trouble, with too much fishing pressure and abundance declining. But there are many success stories with fish stocks maintained at productive levels and any overfishing either rare or being reduced. A critical question is, why is the status of fish stocks good or improving in some places and poor or declining in other places? In a paper published in the Proceedings of the National Academy of Sciences on December 19, 2016, Mike Melnichuk, Emily Peterson, Matt Elliott, and Ray Hilborn showed that the answer appears to be pretty simple. Countries that have effective fisheries management systems generally have healthy fish stocks, while countries without effective fisheries management typically have low or declining abundance and increasing fishing pressure on fish stocks. They conducted a survey of how fish stocks around the world are managed. Their survey was conducted in 28 countries, which account for 80% of global fish landings, including the top 20 countries in terms of total landings. They relied on people familiar with the fisheries of a country, aiming for a mix of people from different backgrounds, including backgrounds from government managers to environmental NGO workers. Overall, they conducted 191 surveys with data on 413 individual fish stocks. For each fish stock, there were 41 specific questions about the fisheries management system. The management questions were grouped into 4 classes: research, management, enforcement, and socioeconomics, and covered a range of elements in each class. In addition, they asked another 5 questions about the current status and trends in abundance and fishing pressure for each stock. Some typical questions are shown on this slide. The first is under the research category. The second is under the management category. The third under the enforcement category. And the fourth is under the stock status category. For each question, the survey asked for an answer of either 1 if the criterion was met, 0 if it is not met, or 0.5 if it's partially met. For stock status, survey questions reflected whether stock abundance and fishing pressure were currently at desirable levels with respect to management targets or trending towards desirable levels. Aggregating these measures, they found that overall, the United States, Iceland, Norway, Russia, and New Zealand had the healthiest fisheries, while the Philippines, Bangladesh, China, Brazil, Nigeria, Thailand, and Myanmar had the most depleted fisheries. This figure shows the average score for each country for each of 5 different aggregate measures of the management system and the status of the stocks. These measures were highly correlated. In other words, the highest scoring countries tended to score well across all measures, while the low scoring countries tended to score poorly across all measures. But there were exceptions. For example, India scored quite highly on research, but less well on management and enforcement. The authors aggregated these first 4 categories, research, management, enforcement, and socioeconomics, into an overall Fisheries Management Index. This map shows that aggregate measure, which represents the overall intensity of fisheries management and effectiveness of management systems at meeting their objectives. In general, the poorest scoring countries were found in South and Southeast Asia, while the highest scoring countries were in temperate latitudes of both northern and southern hemispheres. The authors wanted to explain some of this observed variability among countries. They considered several external factors that could reasonably affect the effectiveness of fisheries management systems in these countries. They considered influences of geography, of population and reliance on seafood, of economics, of the magnitude and history of fishery catches, and of subsidies that governments sometimes provide to fishing fleets. They considered these factors all together in a regression model to see which ones most strongly affected the Fisheries Management Index. They found that economic factors were particularly influential. These figures here show the observed relationships between three of the factors with greatest influence, shown on the horizontal axes, and the Fisheries Management Index, shown on the vertical axes. Data points show individual surveys, and the lines show the mean relationships across all surveys. The thick black line shows the average relationship, and the colored lines show the influence of the background experience of respondents. So government managers and scientists tended to give more favorable views of management systems, while representatives from environmental NGOs and external organizations like the Food and Agriculture Organization of the United Nations tended to give less favorable views on average. However, this influence was minor compared to the influence of per capita GDP on the Fisheries Management Index, which we see in the plot on the left. Richer countries tended to have more effective management systems, probably simply because they can better afford more intensive management. However, after controlling for this factor, we still see influences of other economic factors as well. The plot in the center shows the influence of bad subsidies, that is, subsidies to fishing fleets which enhance fishing capacity relative to the value derived from fishing. Countries with a greater index of capacity-enhancing subsidies tended to have less effective management systems. The plot on the right shows the influence of good subsidies, that is, investment in the management system. Here we see that countries which invest more into research, management, and enforcement do indeed have more effective management systems, as one would hope. Next, the authors wanted to identify which particular attributes of fisheries management systems most strongly affect the status of fish stocks. To answer this question, they looked at the influence of individual attributes on the current stock status and trends in abundance and fishing pressure on stocks. These attributes fell within the research, management, enforcement, and socioeconomics categories on their fisheries management expert survey. They considered the 13 attributes listed here that would normally be used to construct the Fisheries Management Index, but in this case, they considered those attributes individually. The authors found that 3 of the 13 attributes were particularly strong in leading to more desirable outcomes for stock status. These 3 attributes were the scientific assessment of the status of the stock, the ability to limit fishing pressure, and the enforcement of fishing regulations. These 3 figures here show that higher values of these 3 attributes led to more desirable outcomes of current abundance, trends in abundance, current fishing pressure, and trends in fishing pressure. Here, the values on the vertical axis are arranged so that more desirable outcomes are always higher. We see that countries with less extensive stock assessments, weaker limits on fishing pressure, and less comprehensive fisheries enforcement tended to have less desirable outcomes in terms of the current status and trends in their fish stocks. The authors suggest that sustainability of fisheries results from a well-functioning management system, and the nature of the management system, more than the current abundance of fish stocks or the history of catch, is a better reflection of sustainability into the future. Improving the performance of global fisheries will be best achieved by improving the fisheries management systems in the countries that currently have less effective systems, as represented by the Fisheries Management Index. These improvements may be especially likely by building capacity to perform stock assessments, restrict fishing pressure, and enforce fisheries regulations. The authors believe these general lessons apply both to the large industrial fisheries and to small-scale artisanal fisheries, but the tools needed to assess and manage small-scale fisheries are certainly different from the tools needed for industrial fisheries.